Okay, I think
Amazing. We are live, I guess.
we are live. Yeah, that's what it says over here at least. Okay,
Brilliant.
great. Hi, welcome everybody. Hope you all had a good and relaxed Christmas Day celebration. This is a gift from Stempiers to all of you. We have Aryan Mishra with us. He doesn't need much introduction, but we'll say a few lines. Aryan, he's a young astronomer. He has taught over 300,000 students to date. He has been featured in Humans of Bombay and the New York Times. And he discovered an asteroid along with his friend at the age of 14. So Aryan and Stempiers collaborated over the summer to hold a summer astro school. And now he's back again to talk about how stars and galaxies are formed. So all over to you, Aryan.
Amazing. So before even I begin something, let me thank a couple of people. And first should be Sohini, you. Thank you
Oh,
for making this everything like right at the place. Then the second thank you should go to Abhinav. Abhinav, thanks for creating everything and making it perfect. Then I should also thank Ananda because Ananda is the man who has like literally showed me the way to Stampier. So everywhere doesn't matter if Ananda is there or not. The credit should always go to Ananda. And I should thank Monica also for the posters and everything. And thank like in general, thanks to everyone. So rather than getting into much, I will share my screen and then we will head to the presentation. So I'm not that kind of pretty artistic person who does a lot of good presentations and everything, but I am trying my best to make it look very simple. Oh, so yes, here we go. So so the main objective of this talk, Journey to the Stars, which I'm giving today, is not about my journey to the stars. It's simple that when we look up at the night sky, we always imagine the stars and their beautiful stars, every color. Every star has a different color. Some is orange, some is white, some is blue, some is red, some is green, like multiple colors. So every might, for me, it might see as an orange, but for someone, it might, for, for someone, it might be red, or someone might be something else. Every star has some mystery around it. That's what we're going to learn today. Journey to these stars. The main focus of this lecture is to delve into uh, a more in a simpler manner. I haven't took anything a very high level stuff. Okay, that nobody will understand anything if I speak. So I personally feel like that if you can't explain physics to anyone, then this means you only don't know physics. So I'm that kind of person. So even I'm learning physics, so I'm sure there's so much I will learn today. So let's go at the beginning of the universe. So a lot of things if we talk about, so how did universe started, it's like how did the universe started. Often people will say, oh, it's because of Big Bang. Some other scientists will say, oh, it's because of this, but nobody knows. There's no solid proof, you can say, or it's, there is no nothing you can tell everyone that okay, this is what happened, because there are multiple things. Science works on observation and proofs. But the solid and the most say what humans and other astronomers and they believe that is only on the Big Bang. If I have to move forward, then the universe emerged as a hot density of matter and energy. As the cosmos expanded and cooled, it spawned galaxies, stars, planets, and life. That's how the evolution of the universe started. And this is, I'm talking somewhere around 15 billion years back. Our understanding of the genesis and evolution of the universe is one of the great achievements of 20th century. And the reason why we have been able to achieve is the massive amount of science we have been doing, the biggest telescopes and everything that we have come up. It heads us to know more about the universe and the evolution of the universe, the starting and the beginning of the universe. So I'm taking 15 billion years as a rough amount. So let's take at a particular instant, roughly 15 billion years ago, all the matter energy we can observe today concentrated in a region smaller than a dime. Scientists often believe everything started from a single atom, right? And the fusion happened, like a lot of things started happening at one atom, and slowly. It's that's what I say. It's smaller than a dime. Began. that atom started began to expand and cool at an incredibly rapid rate. And then, we say big bang. So if you see the word big, it means massive, and bang means boom. And that's where the boom happened. And the matter started expanding in the universe. And in the universe, that's what we see today. It spawned galaxies, stars, planets, and life. So that's what astronomers believe, that the universe started from Big Bang, from a single atom. The modern day telescopes on the ground and in space detect the light from galaxies billions of light years away. Every star that we see tonight in the night sky, for example, this is a winter right now. If you go to watch any of those constellation or even any particular star, it is at some 30,000 light years away, some 4,000 light years away, some 4 light years away. It is all possible because we have been observing those stars and everything because of the bigger telescopes we have, showing us what the universe looked like when it was young, right? For example, if I look at Jupiter right now, for example, so it will be 1 or 2 hours back. But if I look at some star, which is some million or billion light years away, so when I'm looking at the star through the telescope, this means I'm looking at a billion years ago. It tells us how the universe formed. The more farther we look in the universe, the more we can tell about ourselves, how the beginning of the life started. Satellites detect the cosmic background radiation left over from the early stages of expansion, providing an image of the universe on the largest scales we can observe. Now, I used a word known as cosmic background radiation. So we learn about this अभी थोड़ी देर में. So, but if we see, so we say Big Bang theory. So astronomers early in time, we name it as standard cosmological model of the universe, the beginning of the universe, or you can say standard cosmological model or Big Bang cosmology, right? Our best efforts to explain the evolution of the universe, the entire wealth of data are all together in a theory known as the Big Bang theory, right? The major claim of the theory is that in the large scale average, the universe is expanding in a nearly same way from a dense early state. And the major claim of the theory is that the large scale average, the universe is expanding in a nearly homogeneous way from a densely early state. That's what I've mentioned in second last point. So if I had to look in a more closer manner, so although there are certain, like, so when I say large scale average, the universe is expanding from a nearly same way. This means there is not much changes till now we have been observing. We have been seeing it just expanding, right? And astronomers are not sure, for example, how the galaxies were formed, right? But there is no reason to think the process did not occur, right? We don't know that how did Big Bang happen, but we are not saying that the Big Bang didn't happen, right? So it's just simple, we don't know how. So, for example, there are no concrete theories or proofs that, okay, how the galaxies are formed. But we are not saying the galaxy didn't form. Indeed, the predictions of the theory have survived all tests today. The theory is not proved yet in a very, very solid manner, but we still believe in Big Bang theory. And the theory says that everything started from in a homogeneous way from an early state to a dense matter. That's what I said, single atom. And that's how the universe began. It started expanding. And a lot of theory came, especially the Einstein's theory of general relativity. Einstein did a brilliant work telling us how we have been looking at the universe. So theory of general relativity. I will not get into much of general relativity because it will take a lot of time. But it it tried to show us the space, time, and mass. Everything is interrelated, and that's how Einstein tried to prove the theory of general relativity. But in 1922, the Russian theorist Alexander A. Friedman realized that Einstein's universe is unstable. So he tried to say Einstein tried to say that everything was happening in a constant manner, right? Everything is interrelated. Everything is happening in a constant manner. But Alexander changed the theory, and he said that the universe is unstable. We don't know at what time what can happen, right? So we don't know at what time it can expand. We don't know at what time it can contract. And at that time, Vesto M. Silfer of Lowell Observatory in Arizona was collecting the first evidence that the galaxies are actually moving apart. And this was the most breaking discovery in the 1920s that happened, that the universe is expanding. How do we know the universe is expanding? That is the most important thing. There is this thing known as redshift. I haven't mentioned this, but I thought of telling you. So what happens is that if the galaxy is moving away from us, right? For example, Edwin Hubble, the famous astronomer in 1929, the eminent astronomer, saw from the Lowell observation that when he started using the telescope, he started observing that the one galaxy and another galaxy are moving away from us. And how did that happen? Because of redshift. He measured the redshift. Redshift basically means that when light starts from a galaxy, and if the wavelength of that galaxy is on red means that the red color is traveling the higher wavelength. This means the galaxy is moving away from us. So one to the another galaxy. That is one of the ways. There are multiple ways to find that the universe and everything is expanding. But this is one of the redshift from we have been using from the early stage. Now there is parallax. Now there is multiple things that we know how to. But at that point of time, redshift, because spectroscopy was very popular. Right. So yeah, and now our if I will add some more points also in the uh, uh, is that if I will add one more thing about the Big Bang, is that at present there are no fundamental challenges to the Big Bang theory, although the theory has some unresolved mysteries within it. Astronomers, as I said, that they are not yet sure how the galaxies were formed. That's what I've been trying to say, that we are not saying. I'm not trying to say that the Big Bang didn't happen, but but what will happen in the distant future when the last of the stars exhausts the supply of nuclear fuel? No one knows the answers yet. But look, what I'm trying to say is that what will happen even after this, we don't know yet. So even if we know that the last of the stars which are there at the end of the universe, or somewhere even if they exhaust their supplier, if they exhaust their fuel, what will happen? So what I'm trying to say is that everything has some mysteries around it, and the mysteries are mind blowing. So that's what uh, astronomers, they have been observing since 1920s, and they have been trying to make uh, you know a lot of observations. And I say, when there is a lot of data which comes up, a lot of discoveries happens. And now our main objective, and I said the journey to the stars, mainly focused on how stars are formed, right? Every night when I go and look up, right now from here I can watch some of the stars, and I always imagine how stars are formed. For example, I am born from my mother. Humans are born from their own mother. Animals are also born. So that's where stars are also born. But the interesting part is that to get like a baby takes 9 months to get born. But in the same manner, stars can take at least 10 million years, or some of them can even take more than that. And now, in a very simple manner, I will tell you how stars are formed. Stars are born from a clouds called nebulae. A typical nebula is many light years across and contains enough mass to make several thousand stars the size of our own sun. The majority of the gas in nebulae consists of molecules of hydrogen and helium. The second point is very important. A star is born when atoms of light elements are squeezed under enough pressure for the nuclei to undergo fusion. Now, remember, what does this word mean? Undergo fusion. If you don't understand what fusion means when two or like one or two things are getting, say, inside each other to make a third product. So A plus B, they're getting to make a C product. So that's how fusion happens. So this means there was, if I have to say, the star is born when atoms of light elements are squeezed under enough pressure for their nuclei to undergo fusion. Right? That's what the third point is. That is what the third point is trying to tell. All stars are the result of a balance of forces. The force of gravity compresses atoms in interstellar gas until the fusion reactions begin. Means uske upar so sorry, I start keep keep sometimes I start keep speaking in English, so don't mind it. So sometimes what happens is that the interstellar gas, the gases present inside the nebulae or inside the star, they start getting compressed, and once the fusion reaction begins, they exert an outward pressure. As long as the inward pressure of gravity and the outward force generated by the fusion reactions remains equal, and the star remains stable. That's how a star, the inner fusion starts. The outward and inward pressure should be equal, and that's how when the reactions will start. So, if I have to look in a very similar manner, I remember. I hope you remember in the beginning I mentioned this cosmic background radiation or cosmic microwave radiation. What I was trying to tell you from this is very simple. CMB, we often say, was discovered by in 1960s by Anno Penzias and Robert Wilson. it gave multiple proofs about the Big Bang. So what does this cosmic microwave radiation or microwave background radiation, or in smaller we say CMB? CMB is the oldest light we can see, the farthest black spot in time and space that we can look. This means when the Big Bang happened, the CMB only started at that point of time. This light, the radiation, set out on its journey more than 14 billion years ago, long before the Earth or even a galaxy existed. It's a relic of the universe infancy, a time when it is not even in the cold, dark places it is now. So this means it is all started when everything was beginning. CMB gives us a multiple proofs of the Big Bang. What Wilson and Penzias they were trying to say that Big Bang happened because of four fundamental forces that we also called as the four fundamental forces of the universe. That is gravity, electromagnetism, strong and weak nuclear forces. And I'm sure four of them, everyone most probably will be clear that what they in normal language they mean. I will not get into much of the four forces, but what I'm trying to say is that the familiar objects that surround us today, stars, planet, galaxy, whatever we see, eventually they became from these particles when the universe expanded and cooled. That is from the cosmic microwave radiation. So this theory is one of the good proof for the Big Bang. Now, as I said, how stars are formed. It's a very beautiful picture clicked by in Alma in Chile. So here I'm going to focus on the phases of a star. Uh, so I'm going to tell you. So for the next, say right now it's 8:46. So for the next 20-25 minutes, sit back and just relax and just. I'm going to teach you like, I mean, in stage one, stage two manner that how stars are formed. See, everything starts from one atom. Everything which is anything which is in the universe is made up of our body is made up of atoms. Everything one piece gets together, and that's how the entire one thing forms, and that's how everything's become as a whole object. The first stage of a star is known as a protostar, stage one. When a protostar gets smaller, it spins faster because of the angular momentum, increases pressure, creates rising temperature, and it enters second phase, that is T-Tauri phase. Now, when the angular momentum increases between the core of the star, that is the first stage, or is known as protostar. It increases pressure and increases temperature. Increases, right? And so also this doesn't mean it happens in one day or one night. It might take millions of years to get protostar to T-Tauri phase. It depends on the size of the star. T-Tauri stars are less than about 10 million years old. This early stage lasts about 100 million years before nuclear fusion kicks in and it becomes a true star. Now, stage one, stage two might take even 100 million years. We are just taking an approximate value. Nobody knows that it might even take some more years than that, or even it might take less than that. We are just taking nearly 100 million years, for example. The first stage is protostar. That's where the star is getting more. That is, let's divide it into the months. The first 3 months, it's protostar and is T-Tauri, right? Okay, again, this I'm taking example 1 to 3 months. ऐसे करके I'm just trying to tell you. Protostar and T-Tauri. Now, the third and the most important sequence which comes up is that after millions of years, later the core temperature climbs to 50 million degrees Celsius, then it becomes main sequence star. Right? If you see these two stars, also notice their color. Left hand side is little yellowish, orangish, reddish. Right hand side is pretty bluish. Right? In between, you can see white go. Right? What is main sequence star? Now, the main sequence star is the most important phase of a star because 90% of the star lives just depends on the main sequence star. Always remember there are two types of star: average star and massive star. Right? For example, Betelgeuse is a massive star as compared to our own sun. Betelgeuse is an Orion constellation, and our sun, or the sun in our solar system, is an average star as compared to the Betelgeuse. If we compare both of them, these two stars are Pollux and Castor of Gemini constellation. Right? I think I forgot to write the credit of the picture. I'm sorry for this. I think this is from Hubble Space Telescope. Our sun and many other stars are main sequence stars. So mostly All of the stars which shine very brightly and if you see in the night sky are of main sequence stars. Many stars remain as a main sequence star for millions of years. So now, if you look at this back galaxy at the back there, these this is Pinwheel galaxy. I don't remember the Messiah catalog number of this galaxy, but this is a amazing Pinwheel galaxy. Uh, Now, the most important thing which comes up, look at this amazing picture at the back. You will see bands of the galaxy. You will see that lots of stars. Some you can also make out some of the colors of the stars, right? So, as I said, every star has a different color. Now, the agenda which comes up is that why do they have different colors? Always remember, stars are made up of hydrogen and helium. As the best example is sun. Hydrogen gets converted into helium, the fusion happens. That's how sun radiates X-rays. That's how sun radiates different energies, and that's how we get heat. The heat radiating X-rays, when I said in the first line, the star exists in a stable that of a nuclear fission converting hydrogen into helium and radiating X-rays. If the same X-rays reaches Mars or other planets, because they don't have a good atmosphere like we have, they don't have layers like which saves us. They don't have 7 layers of atmosphere, some of the planets. That's why you cannot live on those planets, right? But Earth has 7 layers of atmosphere. We have ozone layer, stratosphere, ionosphere. All of these rays, when it starts from the sun is a star. It comes to the and it gets reflected by the atmosphere and it doesn't reaches the Earth. That's why we say if the more pollution happens, if the climate change happens, in coming years, ozone layer will start getting depleted. I'm sure you must. These are common words which we may have read over the news. That's why we say so. The X-rays which will come to the Earth will not get reflected back. We will end up getting even different kinds of disease. Most probably, we will be dead. Nobody will survive. Right? Hot star appear white and blue in astronomy. This is very interesting. Even I used to get confused in the early time that hot star must be red, but it's ulta here. It's opposite. That hot star appear white and blue, cooler star appear orange and red. I think I haven't mentioned about this person because we have less time. I have only uh, say 45 minutes to deliver this lecture, but I'm going to tell you a book after this. I'm going to show you here. It's a brilliant book on Cecilia Payne. What stars are made of. I think everyone must read it. I'm going to tell you later about this. So, as I said in the previous slide here, that uh, when core of any star like the core of the temperature climbs to 15 million degree, it will be a main sequence star. Even our sun's core temperature is somewhere around 15 million degrees. Stars spend their 90% of their lives in the main sequence star phase, as I mentioned earlier. So now we talked about stage one protostar. We talked about stage two, that is T-Tauri phase. Now we are talking about stage three, that is what? Main sequence star. Now we have already passed 90% of the star's life. Now the 10% of the star's life is left. Now imagine if I'm driving, a time will come when there will be no fuel left in the car and the car will stop. This means the fuel is over. The car will stop. In the same manner, remember, there are two types of star, average star and massive stars. Now, the 10% of the life which is of any star, it is the time to get to like 10%, whatever, sorry, 10%, whatever the life is left. Now it's time to die, right? So the die, like every star doesn't dies in the same manner. Every star dies in a different manner. Again, it depends on the size of the star. As the star moves towards its end of their lives, much of the hydrogen has already been converted to helium, right? So this means, what does this mean? This means that slowly star's fuel is getting over. Helium sinks to the star's core and rises the star's temperature, which causes the outer shell of hot gases to expand. This is a good picture at the back. It's clicked by Hubble Space Telescope in the Orion constellation. This is Betelgeuse, I guess, if I'm not forgetting. I think this is Betelgeuse. If I'm wrong, let me know. Uh, so if you see, I think let me annotate a little bit. Just hold on. Yeah, let me change the color. That makes sense. This is the this is the core of the star. You will see uh, these are outer gases expanding, right? So this means helium is exactly in the star's core, and its outer shell of hot gases are expanding. They are known as red giant stars. Now there are two types of red giant: like red supergiant, and there is red giant, right? Now the only difference between supergiant and red giant, you can always imagine supergiant will be massive than the red giants. That's the difference. That's it. But the properties of both of the same are pretty similar. Now, if you look at the middle of this very beautiful picture, it's I think it was clicked in 1987. This is I think in Sagittarius. So if you look here, and you can see there is something beautiful phenomena happening. This is a supernova explosion, or I'm sure everybody must have heard of about supernova. If you haven't, then it's amazing. And if you have supernova, it's a very, very beautiful explosion. A very famous astronomer, Carl Sagan, once said that we all are made up of stars, stuff. Or you can say, in short, he wanted to mean we all are made up of supernova. What happens? Supernova. Some stars end their life through a massive explosion known as supernovae. This means massive stars massive, like 50, 60 times bigger than our own sun. When they die, die from a supernova explosion, like massive explosion. And the material which comes out from the core and from the boundaries of the star, right, it starts expanding in the universe from wherever it is at some 15 to 40,000 kilometer per second in the universe. And these blasts produce many elements like iron and thorium, which makes up our planet. So what I'm trying to, in short, I'm trying to mean what, sorry, what I'm trying to mean is that uh, I will drink a little bit of water. Okay, just a second.
While you're drinking water, there are a lot of people who said hi to you on our YouTube live feed. Some of them are saying hi, sir.
Oh, wow,
And we have
I
Raghu also
think
from St. Pierce who's watching over here. And we have
uh,
quite a few people who are watching this live. So yeah.
amazing. So let's come back to supernova explosion. A supernova is one of my favorites explosion because we all are made up of supernova. Iron in our body, sodium in our body is all come from supernova. We all are made up of salsa. That's why what Carl Sagan said that, right? Now, one of the most fascinating topic and one of the most interesting topic that if you ask anyone, oh, do you know astronomy? Yeah, I know a little bit about black holes. What is a black hole? If you ask someone what is a black hole, a place where light cannot reach, right? That's what the mean, or that's what a black hole means. But okay, that's a definition that we are telling one of the properties of a black hole. But that's not a correct definition to define a black hole, right? If a star is so massive, 10 times bigger than our own sun, okay, it leaves behind a large core. Now, let's get back to this slide. Remember, I told you, much of the hydrogen has already been converted to helium. Let's come back to this. It leaves behind a large core. What does this mean? It means there is no fuel left, right? That core has no energy left to fuse, which means no hydrogen, no helium. But it is so massive that has no outward pressure, which may lead to encompass its own gravity and turn into a sinkhole. If I have to, so for example, I'm not sure whether, let me show you my hands. Look at my hands very carefully. For example, the gravity is so high. So you must have heard of, look at this. There is this picture credited known as Event Horizon Telescope. So if you see what the event horizon, in black hole, we say the event horizon of a black hole. Event horizon means the boundary of a black hole. And at event horizon, there is so massive pressure that it starts stretching the star. It starts stretching the star. Let's come back to this slide back again. As the stars move towards the end of their lives, much of their hydrogen has already been converted to helium. Let's come to the second, which causes this outer shell of hot gases to expand. But in this case, we have helium in the star. We still have helium fuel in the star. But in this case, what is happening? There is no fuel left, neither helium nor hydrogen. But still, it is trying to expand It's still. And when it starts expanding so powerful and it's such high pressure increases that it creates a sinkhole that is known as a black hole. Now, what happens? Why do I say when light goes to the black hole doesn't comes out? For example, so if you look at my screen, I don't know, but let's do one experiment. So this is my phone. I don't know whether flash will happen or not, but okay, there is no flashes happening. So for example, I don't know. Let's not waste. Uh, so let me. I wanted to show you one experiment. Let me find my another phone. Okay, I have. I don't know whether flash will. So let's try it. Chanak say it got in my mind that I can show you this. Oh yeah, I think this can. So if I'm trying to click a picture of this, for example, you are the black hole, okay, and the camera is the black hole. So I just click a picture and the light goes. So you can see the light, you can see. But what happens in a black hole? If I put my camera in front of a black hole and if I click the image, entire light will go inside the black hole, but the light will not come back. So this flashlight will go inside the black hole, but nothing will happen. So what is the interesting property? What I like about the black hole is that you can't see a black hole. Why? Because it is black. But then how do we find a black hole? That is the most important question. We astronomers, we do X-ray imaging, gamma ray imaging, multiple, lot of stuff, lot of science, right? From massive telescopes. So what we do is that we start watching our galaxy, or say we start watching some X portion, for example. We start watching an X portion and we start observing that some of the stars slowly in the coming years, they have wiped out. They have stopped radiating energy or say radiating any light. This means there is some property or there is something there to eat. I'm using a word called wo usko kha raha hai, which means it is eating. So black hole eats the star. This means all the light of the black hole goes inside and the stars, they don't radiate anything. Or in simple ways, we can say the black hole ate the star. And how we prove there is a black hole, because we start observing the gravitational pull of a black hole is so much it starts eating everything inside its core, or it just starts eating. For example, I start eating a sandwich and I just finish. I don't like sandwich, come on Aryan, I like pizza. Let's take an example of pizza. Sandwiches are pretty. I don't like sandwich. Pizza, I just ate in a pizza 40-45 minutes back, so pizza is a good example. So for example, I like pizzas. Okay, margarita is one of my favorite, and I like spinach and that one. So what's your? Please let me know your favorite also, so I can try it. Uh, so the fascinating thing about black holes is that what fascinates me about the black hole is that you can't see something. When you can't see a thing, how can you find that thing? That's where the science happens. Because now look at this image. This is somewhere around 68 million light years away. Now what you're looking at, this image is clicked by Event Horizon Telescope. And this image is not one image. This has been clicked by multiple millions of images being stitched observed through 68, more than I think 60 telescopes around the world: Australia, Chile, South America, everywhere, Mexico, everywhere. Different telescopes, they were shooting at one place and they were trying to see what's happening there. And in between, in this image, which you can see a circle, that is the black hole. And this yellow, this orangish thing you are watching, these are the stars radiating the energy. So this is a black hole in the middle of a galaxy, and there is a black hole inside this thing, our Milky Way also. So not taking a lot of time on black hole, I can speak like 1.5 hours easily on black hole. So I get very much fantasized. So I will not get into too much black hole. So but let's move forward. And a
Aryan,
very beautiful phenomenon.
there's one question which says, but it radiates too, right? Like, this is a question by Nitin who asked.
Sorry.
With respect, he's asking, but it radiates too, right?
What radiates? The black hole radiates?
I'm assuming that's what I'm.
So Nitin,
Just,
can you just tell me like what radiates? So the black hole radiates, or what is radiating? So if you can just explain a bit. I'm just looking at
there's
the
another
question.
question we'll come back to later, which is about
Yeah,
your
yeah.
sandwich. Not liking sandwich, but we'll come back to that later once you're done.
Sure. So yeah.
Yeah, Nitin, if you could just say what the distortion of space generates radiation. That's his question.
The distortion of space generates radiation. It yes. If it's a massive object, then the distortion will. In physics, we say distortion. We define a word. Stephen Hawking always defined this word entropy. Entropy. That is the word we use to define the distortion of space. The entropy gets disturbed. So if distortion is happening, then you know Hawking radiation. Sometimes we say Hawking defined this distortion of space. So in Hawking's word, we call this as an entropy, and the distortion also generates radiation. That's true. That's true.
Okay. And then we have another question, which is how do we calculate how far a star is?
Oh, there are multiple ways. There are multiple ways to calculate. One of the easiest ways to see its wavelength, how far the wavelength is traveling. And for example, we have to measure two stars together. So if you have to define the distance between one star to another star, you have to measure the wavelength and see if the wavelength is higher on the red side. This means that star is moving away from the other. And if the other star's radiation is also higher on the red side, this means they are moving away. Both of them are moving away. But if, for example, if one of the star's radiation is lesser on the bluish part, this means it's not moving, it's there only. So that's how we define one of the this is easiest way. We have been using this method for more than 100 years now. This is known as redshift, and this we also use in to define the galaxy, to define uh, uh, the distance between galaxies and stars also. So yeah, and there are multiple 2 3 other ways also. So those are some massive sciences, parallax and all the things. But again, like the easier way, which if you ask me to find the distance, I would choose redshift, because now we have such amazing technology that we can measure any of the wavelength, and we can just find ki dude, where are you, what's up with you, where are you going. So we can do that easily now. So now let's come to, you can see a very fancy picture, such a cute picture. It feels like swimming pool ki chalo ek dip maar lo. So this is it looks like a swimming pool. It's a very fascinating image. This is called a ring nebula. It's a planetary nebula, and if you see this, it forms like a planetary structure also. So planetary nebulae are the cloudy remnants of a smaller stars that have shed their outer layers of gas that haven't been exploded into supernovas. Now, do you remember in the previous slide, red giant star, I said that the outer layers starts getting expanded. That's where sometimes those they become a planetary nebula. And there is a very interesting part, about astronomy. If you die, you don't just die; you create something else also. So one thing keeps dying, and it keeps making something. For example, a supernova, a star dies, a core collapses. It forms other things also. Some of the things form quarks, or some of the things form neutrons, protons, neutrons and protons. A lot of things. Like I will show you at the end. But the first planetary nebula was discovered by the Dumbbell Nebula N27 by Charles Messier in 1764. And also, I remember a very interesting thing. I think I haven't added in this lecture. Earlier, people used to think that nebulas are galaxies. There was no words like known as nebula. Everyone used to, when they used to observe a nebula, they used to tell them it's a galaxy. But Edwin Hubble was one of the first people, which I think no, sorry, sorry, I said it opposite. So in earlier times, when people used to observe nebula, uh, yeah, when people used to observe galaxy, I just got a little confused. So people used to, when they used to observe galaxy, they used to say that it's a nebula. But when Edwin Hubble in 1920s, when he observed through the Lowell Observatory the Andromeda galaxy, at that time it was called Andromeda Nebula. But he defined the difference between a nebula and a galaxy. So he said that it's not a nebula, it's a galaxy. So that's where people, because there was not massive telescopes. So the building of telescopes started happening in 1800 from the northern part of the America. From 1800s, when it started coming up, the biggest telescope when it came is over a 40-inch. Then it came 60-inch. Then later in Arizona, it came as 100-inch. Now we have massive telescopes. There's no words to describe the beauty of the telescopes. Okay, neutron stars. I hate neutron stars because it just goes sometimes above from my head. I was like, इसके बारे में जितना कम बोलो उतना ठीक है. Because this is not my area of research. Neutron star, white dwarf star, black dwarf. I'm not interested in all this. But if you have to explain stars, then dude, you have to tell what is a neutron star. So I'm more into like a little bit planetary science, but neutron star मैं बस जितना लिखा है उतना ही पढ़ता हूँ, उससे ज़्यादा I try to remain is that thing. So because neutrons are very complex stars, neutron and neutron stars, white dwarf, they have been from the beginning of the universe. They are not something which has happened recently. They have been there from a very longer time. Since a lot of people they describe neutron stars as a part of the dark matter or a lot of stuff. Neutrons are thought to form by gravitational collapse of the remnant of a massive star after a supernova explosion, which means when a supernova explosion, when everything starts getting expanded. So these are the tiny stars which gets formed. But the interesting part is that they are like the Earth only. Some of them are in the similar size of the Earth with a radius of 30 kilometers, which is pretty less as compared to the you know massive stars like the sun. So and but the interesting part about these neutrons is that they're very powerful. Like they spin very fast as compared to other stars. Like they start spinning very fast. That's why sometimes they're easy to locate also in some of the part of the galaxy. But also every star. So when I look at it through a telescope, doesn't mean I will observe every star. That's why we use gamma filters, X-ray filters, and everything. Then only you can observe multiple stars, right? That's how we were able to define dark matter and difference between dark energy. So the interesting part about white dwarf is that when a star dies 8 times massive than our own sun, its life depends on the mass it was born with, and the star turns into a white dwarf. Now let's come. I will come back from here. So one, two, three, four, five, six. I told you six different ways a star can die and it can happen. So as I said, we don't know how a star will die. It just depends on its size. We can make a prediction, but the universe is so complex and is so amazing that at any time anything can happen. So if I think that it will become a white dwarf, I'm not sure. Okay, it might become, but it might end up becoming a neutron star also. So it has, and this has been observed. That is why universe is so unpredictable. And what black dwarf and white dwarf are both similar things. The only difference is that the color. Simple. And now comes to the end of it. I'm going to explain this in a very whatever I just spoke. You guys, I'm sure you guys must have got bored too much. Sorry for that. But we started from protostar, then we went to T Tauri phase. Those are the two initial stages of the star. Right now, we come to, as I said, average star and what massive star. Massive star known as high mass star, average star as low. So you see this slide, so upper wala, the upper part is the massive stars and the lower is the average stars life. Everything starts from main sequence star. Always remember, everything starts from main sequence star. Then it goes to red giant, supergiant, supernova, black hole, or neutron star. As I said, do you remember neutron star are remnants of a supernova explosion? So it depends. Again, nobody knows from a supernova it might form a black hole or it form a neutron star. This is what the universe is all about. Main sequence, average star, main sequence star, red giant, planetary nebula, white dwarf, black dwarf. That's how everything happened. This is the exact life cycles of star. I think this one I took from Khan Academy. This poster is from Khan Academy, if I'm not wrong, because there is no credentials has been mentioned. It just on my slide. So this I think this is from Khan Academy. If I'm incorrect, just let me know. Uh, so yeah, that's what the life cycle of stars are, and that's what the talk was all about. And
That
thank you,
was
everyone.
that was
Uh,
fascinating, Aryan. And yeah, I think you explain everything so well. And then with this final, just a whole overview that brought the entire picture together. And I think that's great. We do have quite a few questions over here. So we'll take them one by one. Uh,
yeah. Before that, let's watch a video. Okay,
sure, sure.
we will watch a very one of my very favorite video. I'm gonna just put that on slide. Just 1 second. I'm gonna.
Mhm. Take
Uh,
your time.
the reason why I'm showing you this video is that I hope everyone in their once in their life must go at this place. It's one of my favorite. And okay, I have not been there, but I'm just still telling you guys to go. Let's watch this fascinating video.
Okay, absolutely.
Can you hear the audio? Can you hear the audio?
No. We have the visual but can't hear the audio.
Oh, you can't hear the audio. I
No.
think you can't hear the audio. No, just a second. I will just one option. I will disconnect my. I think you might hear now. Just let me know if you can.
Step out at night and look up at the
Can
sky.
you hear now?
It is mesmerizing.
Ladakh, India is home to one of the highest optical telescopes in the world. Its environment makes it ideal for stargazing.
When we step out at night and look up at the sky, it is mesmerizing. We can see clearly the constellation, the galaxies, and the stars. My name is Sivang Durje, and I'm working here at Indian Astronomical Observatory as mechanical engineer.
The Indian Astronomical Observatory is spread across 120 acres of land and located at the northern tip of India.
It consists of two optical telescope, 2-meter telescope, point 0.7-meter telescope, and array of gamma ray telescope.
The remoteness of its location makes it ideal for astronomical study. Kandy is a very good location for sky observation. First of all, entire Ladakh is actually high altitude cold desert. It is in rain shadow region of Himalayas, so there is very little rainfall and hardly any snowfall. So cloud cover is very little. So observations are possible almost throughout the year. We are mainly observing two type of sources. Firstly, we observe objects called pulsars. Secondly, we are observing some sources which are outside our galaxies. These are active galactic nuclei. The observatory's altitude of approximately 2.5 miles above sea level allows the scientists to collect a wider range of data than they would at lower levels. But the isolated location means that often the only other people the scientists and engineers see are the occasional tourists.
We receive lots of visitors, mainly in summer, who are wanting to see the telescope.
When I came here first time, I was quite impressed to see the quality of sky here. Extremely clear sky. It's just amazing experience. Whether you're looking up as an astronomer or just a traveler, there's no night sky quite like this.
That's a brilliant. That's a brilliant video. I always show to people because it is one of the brilliant experiences that I often tell people that to go to Ladakh and watch the sky. And let's. I think we are only 10 minutes left,
Yeah,
and we can go ahead with the questions.
sure.
So
I think we talked about, okay, I think we can start with a question from Purvi which says, do stars collide within themselves? How and why?
uh, they do. Some of the stars they do collide. The galaxies collide. The stars because see the collision it can happen from multiple ways. One of the good like one of the easy ways that both of them are coming in the same manner. So for example, two of the stars are moving in the same direction. If you and me,
So, honey, if you and me are walking in the same direction, we will end up hitting. So, please, we should not do this. But we should walk properly. But still, like for example, if we walk in a similar direction, we will end up hitting each other. That is one of the easiest way to collide with each other, right?
Okay.
Uh, and other ways are that some, for example, any of the stars are gravitational pulls. For example, the best example it can be is for example, let's take I'm not sure whether this is a good example, but planets, they attract the moons, they keep but that's not collision. I think that's bad example. But what I'm what I was trying to tell you is that the planets and the moons, they keep rotating around the, but that is what gravitational pull makes it. Collision basically happens when, even sometimes can happen that one star can pull other star together also. So it can
Right.
also happen. And the easiest way is that black hole is a good example because it attracts everything towards it.
Right. Okay. I think that answers that. Then your question is, why does the whole local group move in a same direction?
Uh, so the people who don't know what is a local group is like every galaxy. The galaxies are divided into multiple groups. One of them is a local group. Local group is a part of some dozens of galaxies. I think it has around 50 galaxies or something, which is also which is it's the local group where we have Andromeda and Milky Way galaxy in it. So the galaxies are divided into part of it. So universe is divided. Astronomers have categorized the universe into different parts. One is a local group, then there is a supercluster, and they're divided into superclusters. Superclusters are a group of galaxies present in different parts of the universe. Local
Okay.
group is one of the part of those. Local group, I think the question was why the local group is moving in the similar direction.
Yes.
Yeah, astronomers, they know how the galaxies are moving in which direction. So they have, the way they have categorized the groups is that the galaxy, so one group is moving in this direction, so one group of the moving, so they know how the galaxies are moving. Again, that's where the redshift happens.
Okay.
This is,
Okay.
yeah.
Okay.
So we
All right.
don't, we can't tell at the one time, okay, the local group is moving and in every galaxy. So we measure, we take the distance of every galaxies, and then we make a conclusion. Okay, for example, the galaxy, giving an example, in 100 kilometers there are 60 people moving in a similar direction. And
Right.
so that's why we can say, okay, let's take it as a local group, and all of them are moving in a similar direction. So there is no sign. I'm not saying that all of them can move in a similar direction. They can deflect anytime. That's where the science happens. That's where the universe prediction is, that nothing in astronomy. I should always tell, nothing is nothing is permanent. Anything can happen. Nothing is fixed. I always say nearly, approximately, because there is no approximation. Everything is moving in the universe.
Right. Right. Absolutely.
Yeah.
Okay. The next question is, I think you already addressed this, but also how long does it take to produce a star?
It just depends. Sometimes it depends on the size of a star. It might take, say, 100 million years. It might even take
Hmm.
200 million years. But a star can live for billions of years. It can live for, like, for example, our own sun has been living there for 4.1 billion, 4.3 billion years. So it might live for another 5 billion years. So a star can,
Right.
every day there are stars getting born, every day there are stars dying. So
Right.
yeah, so most probably it will take 100, 150 to 100 million years. 100 to 200 million years if you want to take a
All right. So then the next question we have is, can we see a Hubble Space Telescope from the ground?
That's a cute question. Uh, uh, if you want to see Hubble, we can see Hubble because it's in the lower Earth orbit. It's just 400 kilometers from above from the Earth. We can see it moving in the sky like a star. It's moving in the sky. But if you look through the telescope, it will be little fast that we will not be able to observe it. So if you do a little bit of kind of photography, CCD imaging, high level of quality of photography, you might be able to capture the solar panels of Hubble, or even a small picture of Hubble. But you can see it moving. There is this website known as Heavens Above. Heavens Above. You can search it, and it can tell you where Hubble is passing from right now.
Oh, okay. That's nice to know. All right. The next question is, what is a star cluster? Aryan?
Can you hear me?
No, you just cut off for a while in between.
Yeah, I think my internet is
Okay.
fluctuating a bit.
Yeah, there's some kind of a lag over here.
I think just hold on for a second.
Sure, absolutely.
I think my internet is bad. Can you hear me now properly?
Yeah,
Hi,
now that's
Shahani.
much better. Yeah, the visuals and the audio is fine.
Yeah, sorry.
Yeah, no, that's fine.
Brilliant. Yeah, the question was,
What is a star? What is star
what is
cluster?
a star cluster?
Yeah.
Oh, it's very simple. If you see star, you know what is star. Cluster means group of something. So star cluster basically means a group of a lot of stars. There are different kind of clusters. Some are open clusters, some are globular clusters, some are irregular cluster. All of them. So there are a lot of clusters together. It's known as
Right.
a cluster. So cluster of stars means millions of stars or thousands of stars together at one place. That is defined as a cluster. Uh, you can watch some of the star clusters from the Earth also by observing through telescopes, and yeah, the multiple clusters can be observed from the Earth. Even some of them are visible through naked eye.
Oh, okay.
Yeah.
All right. So there is one question. It's more like a state. If you have anything to comment on that, it says a few days back there was a tweet from Elon Musk account stating that they have decrypted some signals from outer planet species. Do you have any comment on the same? If you've come across this tweet.
Oh, I don't take that guy so seriously.
All right, we'll move on to the. If not, we yeah.
uh, so if I'm just kidding. So the thing is that these things, it has been going since multiple years. That
Right.
we have done this, we have done that. Science works on proof, science works on observations, and we can't work on raw data. We need a definite data. That's
Right.
what physics undergrad second semester they teach you. My professor gave me C minus in my semester because I was just testing the raw data the entire semester. It's just observations, observations. So all these things I'm not saying this can be wrong, but again, let's move forward a little bit, do good science.
Yeah. Okay. So then we have how many stars have habitable planets, and what makes space so cloudy? I'm assuming that's the question.
Okay. Uh,
Yeah.
how many stars have I don't know the number, but I remember there is one star system, TRAPPIST 1b. I think I Kepler 14b. Kepler
Okay.
has discovered Kepler Space Telescope, now it is retired. It has discovered multiple star system which has multiple planets around them. I remember
Right.
one of them, TRAPPIST 1b, Kepler 14b. These are pretty popular. So I don't know the number of how many of them are there, but I
Right.
know some of them. So yeah.
All right. The next question we have is what are zombie stars?
In my entire 10 years of astronomy, I never heard something like this. But
Okay. All right.
so
Yeah. We'll move on to the next one. One question. So you showed the video, right? So that was with respect to the video. It's how can general public get a chance to view the sky through the telescopes in Ladakh?
yeah, so you can write to them. You go to Indian Institute of Astrophysics website. Go
Right.
to the Hanley telescope. There is this email written. Write to them and just say you are very interested in summers. You can go with your family. They can give you. They can. They. I'm not sure whether they will allow you in the night because that's when the science happens. But they can get you inside the telescope. They can give you a glimpse in the morning time or the visitor timing. So earlier it was closed. Now they have opened for the public because now good things are coming up. People are saying science, communication, science outreach should happen on a longer run. And now things are becoming more open to public as compared to it was 1 decade back.
Right. Yeah. Okay. Somebody's asking you for your opinion on the trillion theory.
Uh, I know this guy. He's Ed Lokovich of Canada. Again,
Right.
like he's. It's very confusing. I don't have any comments. Like there are multiple theories out there, so I don't understand the theory first of all. So I don't think I should comment.
Sure. All
Yeah.
right.
So
And I think we covered almost everything, but or maybe, oh, there's one last question. Okay. It says the universe appears in a black space. Is it also considered as a black hole itself?
uh, so the universe appears in a black space. Does it also considered? We can't say black space. So observable universe says we have observed 7% of the observable universe, and 93% of the universe is defined as dark matter. And
Right.
you can say that black space can be. I'm not saying. I'm just using the word black space. This Anjani has used. So
Mhm.
black space basically means that. So there is no meaning to this black space. Does it is considered? We cannot consider universe as a black hole itself, because if universe considered as a black hole, then we will not be doing this Zoom call.
Right.
We will be dead.
Okay. I think we'll take one last question, and then I would like to ask you one last thing, or like just say, one is, how does a supernova completely destroy a star?
It doesn't destroy the star.
Okay.
It is not a destroy. In one way, you can say it's a distortion. Uh, Destroying, right? Destroying what the word is used.
Yeah.
I
Yeah.
didn't see. Yeah.
Just
How the okay? It doesn't destroy a star. It is one of the ways star dies itself. When a massive star dies, it dies in a supernova. It means it's an explosion. And when an
okay.
explosion happens, multiple things get formed. If a massive star dies and if a massive star has an explosion, it might form a black hole. It might form a neutron star, but
Right.
it doesn't destroy the star. It is one of the ways that star dies.
Okay.
And if you're calling the death of a star as a destroying thing, then you might be incorrect. Like I don't think it's the correct way
Right.
to use it, because
Because we're getting something else out of it, which is then
yeah, yeah,
it.
yeah.
Okay, we have questions pouring in. I will take two last questions. That's it. Okay. The final ones. Okay.
Yeah.
We have, what is dark energy?
Dark energy is so if you see in a very simple manner energy, so you understand what is energy. So if you see dark, so first we need to understand what is dark matter which has not been seen yet, but we still say that there is matter beyond our observable universe. We sometimes define those matter as dark matter, but if there is a matter, this means there is some energy also. So we define those dark energy as one of the energies that is running that dark matter, or those energies in the dark matter, in that dark matter region, are known as dark energy, which we don't know yet, but there is some energy out there in those dark matter. That is, if I have to answer in a very simple layman language. Yeah, I think you're mute.
Yes, because we had a lot of snow yesterday, so they're cleaning out the snow. So that's why I don't want that noise coming in.
uh,
Somebody also, you mentioned a book, Aryan, in the beginning, uh, which you
oh
said you're going
yes,
to again. Yes.
we have some good people on this chat, this event. I'm gonna find the book for you. Mm, Give me a second. I'm just finding the book. I think it was on my. Oh yeah, here it is. It is this one. What stars are made up of? The life of Cecilia Payne. Uh, she's a wonderful woman. She contributed her entire life looking up at the stars, the properties of stars, everything what we discussed. So if you want to know more what I spoke about, Cecilia Payne is your go-to-go person. She is one of the most inspiring person in the field of astronomy. And I think everyone should read this book because it has inspired me. So I thought I should speak in depth about stars, and I thought we have only 55 minutes, or say 160 minutes to run. But if I have to speak on a very broad length about her, it might even take me 40-45 minutes just to tell her life work, what she has done. This is the book. If you want the PDF, you can just write me an email. I can send you the PDF, or if you want to buy on Amazon, you can buy this on Amazon too.
All right. Thanks, Aryan. Okay, one last thing I would ask, like if you could say something about the spring school that's coming up with STEM
Oh
peers, and
yeah,
also something about your experience with the summer school.
oh yeah. I'm first of all, I'm sorry I couldn't make the poster of the spring soon. My last 2 days I've been busy. I'm flying tomorrow to Bangalore, and I'm just packing up things from last one day because I'm going to shoot some of the Milky Way there. So I'm just packing up, looking at my camera equipment. So I didn't get a chance to watch it for last 2 days.
That's fine.
So to everyone, I'm running a spring school from second week of January, which will go for 6 weeks every Sunday. We will be there for like 1.5 hours where we will learn different topics, which will start from the learning about, it starts from learning about telescopes, what telescopes are made up of, who discovered it, what are the benefits of a telescope. Then we learn about Pluto, how what makes Pluto so amazing as a planet, the life of Pluto. So it's not about Pluto is not a simple planet. It is one of the most incredible planets we have, and there is a multiple mysteries. It is related to the outermost region of the solar system. And then we also discuss about life on Mars. So it's just like, it's a small packet to your universe to learn more about, rather than only to the stars. You can only learn about planetary science, lot of sciences. And speaking about my experiences in the summer school, it was amazing actually. We got a lot of opportunities. I personally got a lot of you say I made some good friends, and apart from good friends, I learned so much. The enthusiasm of all the kids who came up always inspired me to work more, even harder. I was very embarrassed because I thought these are little kids, and if I don't meet their expectations, then it will go mad. The parents will be like, "कहाँ हमने पैसे फंसा दिए?" So I had to work 10 times more extra hard because I had to make assignments for every school kids. For every summer school kids. Then I had to put all those activities every day. Used to give 5 activities to them. So that's how everything started happening. So it's been a great experiment plus also a great experience also for me. And the feedback was fantastic. I'm not bragging about myself, but I'm just telling
But
you
it
the
was,
feedback
yes.
was, yeah,
Yeah.
it was brilliant. I didn't even imagine it. So I still remember there were a lot of kids who wrote amazing. The parents were so thankful. They wrote like, I remember one of the kid parents wrote back to me and said, आपने इतना अच्छा क्यों पढ़ा दिया कि वो मेरे पीछे पड़ गई है टेलीस्कोप के लिए. And I was like, and the kid didn't eat food for the half of the day because she wanted a telescope. I was like, wow. And it's like, no, now you have to get a telescope. And I think the parents, I told them $600-700 telescope. I think they must have got it till now. I didn't check after that, but I gave them the recommendation you should go for. They said they will buy it. So yeah, it's amazing. And most of the kids who participated were from America and Qatar.
Okay. Okay. So yeah. So for some people who are asking, they can this is being done through STEM peers. So if you're interested, please send a request to the group on Facebook, and we will be announcing it pretty soon. And Aryan, I'm sure you are going to be spreading the word as well for the spring camp.
Yeah.
And yep.
Yeah, I have just sent my email on the chat box, theyoungastronomer@gmail.com. The people who are interested, they can just write me an email, Avish, Anjani, and everyone. Just drop me an email. I will definitely, by this weekend or by most probably next week, I'm going to post all the details about the spring school and I will start working on it. I'm sure it will be a brilliant experience because I always love it.
Perfect. All right.
Thanks,
Thank you
Sohini.
so much. Thank you to you.
Thank you.
It was great. I learned a lot, and so did a lot of people, as you can see from the different questions. And all the fascination that is pouring in through the chat also. Thank you, Aryan. We are so looking forward to the spring camp. And yeah, thank you. And I
Uh,
hope you have a good Bangalore visit.
Thank you, and I will say hi to Avanti. Thank you. I think Avanti got a little hurted because of sandwich, but
Sandwich.
don't. Avanti, I'm just telling you, when I come down next year, if I make it to your place, then please, please change my mind and serve me some good sandwich. And that's how, that's how. Let's see how it goes up. Thank you, everyone. Thanks,
All right.
Sony. Thanks, Sampiers. Bye bye. Good night.